Okay, in this video I'm going to take you through quite slowly the last of the factorisation techniques. This is an alternative version to using the inspection method. The ones I'm going to deal with, well in fact I'm only going to do one example in this short video. I'm going to go through it very slowly, and then in subsequent videos I will do lots more of this type of question a little bit more rapidly so you can get more practice at it. So the type of quadratic expression we're going to be dealing with is going to have x squared, so many x's, and a number on the end. And the number of x squareds will not be 1. If it was just 1 x squared, we'd be using the easy table method to factorise it. So we won't have 1x squared, we'll have 2x squared, or 3x squared, or 4x squared, or 5x squared, and so on. And in the past I've said, let's use the inspection method. But what I found with the inspection method is that many of you can, yes, spot the inspection method and do it very quickly, but there's also a significant number of you who can't do the inspection method very quickly, and in fact struggle to do the inspection method at all. No matter how much time you spend on it, you still struggle to get it. So what I'm going to do is take you through quite a robotic process. It's a technique you can practice and learn off by heart, and it will give you the answer to these factorisations. It's quite tedious and it's a little bit of work, but it will get you there. And as long as you practice it, so that it's at your fingertips when you go into the exam, you will get the answer at the end of the day. Okay, I've put one on the board here to have a look at. We're going to factorise 6x squared plus 19x plus 10. And I'm not going to do it by inspection. So you ask yourself, does it have a common factor? No, it doesn't. Next, is it the difference of two squared terms? No, it's not. Okay, you ask yourself, is it the easy table method for a double bracket expansion? No, it's not, because it's 6x squared, so it's not the easy table method. So what we're going to do is make use of another technique which uses something very similar to the easy table method, but the way it's set out and structured is rather different, as you'll see. Okay, so I'm going to say the following. I know the answer is going to be a double bracket, but I don't put that double bracket down straight away yet. I'm not doing it in the same sort of way as I do the inspection method. This is what I'm going to do. I'm going to leave the 6x squared alone. I'm going to leave that alone, and I'm going to take the plus 19x and I'm going to rewrite it in a different way. Okay? I'm going to replace it with two terms which both of them combined add up to give 19x. What two terms shall I use? Well, we may use a little technique which I'm going to do at the side of the page over here to determine which two terms I'm going to use to replace the 19x with. So here we go. To find out these two terms, what I'm going to do is take the number of x squared, 6, take the number on the end, plus 10, and I'm going to multiply the two together. So I say 6 times the plus 10 gives you a positive 60. 6 times the plus 10 gives you a positive 60. Write that down. And then I look at the number of x's, and we've got positive 19 x's. So I'll write that down at the side, plus 19. And what I'm going to do is replace the plus 19x with two numbers of x's underneath it, which are the same as it, and they're found from this information over here. The two number of x's I'm looking for must multiply together to give you plus 60. Okay, so if you want to say they're multiplying together to give plus 60, and they must add up to give plus 19. You can see the similarity between the easy table method and how I'm working these numbers out, as I did a very similar process when I did the easy table method. Once I found these numbers, however, what I do with them is different from the easy table method. So let's go through it then. Two numbers that multiply together to give plus 60. Well, it could be 60 and 1, it could be 20 and 3, it could be 30 and 2. Keep going, because they've got to add up to plus 19. Well, it doesn't take me much to figure out that the two numbers I'm looking for are plus 15 and plus 4. 15 fours are 60, they multiply to give plus 60, and if I add them together, you get plus 19. So the two numbers, 15 and 4, both positives. So what I'm going to do is replace the plus 19x with plus 15x plus 4x, like so. So that's the same as that. And I'm going to leave the plus 10 exactly unchanged. So that top line now I'm going to replace with that line there. Okay, next, a set process. You take the first two terms and you factorise using the common factor method, just the first two terms. And you take out the biggest common factor possible. The biggest common factor possible, well, there's a 3 that goes into both terms and there's an x in both terms. So you take out a 3 as a common factor. The rest goes inside, for these two terms, inside a bracket. So you say 3x times something gives you 6x squared. Well, there must be 2 and an x. 3x times 2x gives you 6x squared. Next, 3x times something gives you plus 15x. 3x times plus 5 gives you plus 15x. So that there is the same as the two terms at the beginning of the line above, those there. Okay, what next? Well, now we look at the second two terms and we do the same sort of thing. We ask, please take out a common factor of those two terms, and there will always be a common factor that will work. In this case, the common factor is plus 2. So I'm going to take out a common factor of plus 2. Okay, there's not this time an x in both terms, so I can't take any x's out this time. Plus 2 times something gives you plus 4x. It must be 2x. That times that gives you plus 4x. And then you say plus 2 times something gives you plus 10. And that something must be plus 5, like so. Okay, so we get to there. Now, looking at this, you seem to be thinking, oh my goodness, well, I'm sure some of you are thinking, this seems to be getting much more difficult than what we started with. Let's go back and do the inspection method. Well, if you've followed up to here, we're here now, we've nearly finished. Because if you look at these, we've got two complicated looking terms. But if you notice, in each of the two terms, and this will always happen if you've done it right, we've got the same bracket appearing, 2x plus 5, 2x plus 5. The same bracket is in both. So that bracket is now a new common factor for these two awkward terms. So the 2x plus 5 is itself a common factor. So I'm going to take out the 2x plus 5 as a new big common factor. And what's left will go inside a second bracket. So you're going to get 2x plus 5 times something gives you this complicated first term. Well, that something must be 3x. And then we have this bracket times something gives you all of that. Well, it must be plus 2. That times plus 2 gives you 2 lots of the bracket, like so. And if you step back and look at it, you'll see now we have actually finished it. That's it. We have got two brackets, a double bracket, multiplied together, being the same as the original starting line. And that's exactly the answer you would get if you were to do it by inspection method. Now, speaking personally, I would always do that by inspection method because I've practiced it so often I can get that answer coming out very quickly. But I'm sure some of you would struggle, so it might be an idea if you went through this process, learned it off by heart, because this process will work for every single example. Okay, if you were to expand this out, you would, once you simplified it, get the line above. So there you go, there's the factorisation of 6x squared plus 19x plus 10. The method that I've written down at the side, remember, is a very similar idea as we use in the table method, the easy table method for factorisation. But once we've found the two numbers, we use them differently. In this particular method, what we're doing is we are rewriting the number of x's using those two numbers. And then we're applying common factors for the first two and the second lot of two terms. Okay, in the next video I'm going to speed up the process. I'm going to give you lots of examples and do them very quickly using this technique. Okay, that's the end of this video.